it turns out light also does not travel in a strictly straight path. Imagine a very simple scenario where there is a light source and a detector separated from each other. The expectation would be that light, which is registered by the detector, would have traveled in a straight line from the source. However, we now know that light can take any possible path to get from the source to the detector, and that even includes strange curved paths. However, the curved paths will also tend to take longer to reach their destination, and they also tend to vary more in their duration as compared to the paths close to the straight line paths. The light paths that are closer to the straight line paths are shorter in travel time, and their neighboring paths also vary less in their duration. Overall, we get the expected behavior that we see light tending to travel in a straight line, even though in reality, light doesn't completely travel in a straight line. There is also an interesting test for this as well. We can add a barrier with a hole in it, and we can add another photodetector off to the side, not directly in the straight line path. If the hole is large enough, there are many neighboring paths to both detector 1 and 2. The paths to detector 1 are minimal in time and are similar to each other, and so they add up to contribute to the likelihood that light will take those paths to reach it. The paths to detector 2 take more time and vary more in time between each other, so they tend to be reduced in likelihood. In testing, detector 1 receives light while detector 2 doesn't. However, constrict the size of the hole and detector 2 starts to receive light almost as much as detector 1. In this case, only a small amount of light can now get through the hole, but the possible paths it can take to detector 2 are so limited that even the few paths available now take a more similar amount of time relative to each other and hence reinforce to make it to the detector.